Hello students, a very warm welcome to JEE English by Unacademy, India's leading and largest JEE test preparation platform. And we are on the last part of your gravitation PYQs. We have so far discussed your JEE Advanced previous year questions, JEE Mains previous year questions. We in fact had 10 to 12 lectures on your gravitation, or 10 to 12 or 15 lectures on your gravitation theory. I believe with this your preparation around gravitation should be complete, and today we in fact have some of the last most interesting questions of the session. Let's get into that. And before that, students, do not forget to like and share this video. Do definitely share it on your social media like WhatsApp groups, Telegram channels, etc., because definitely someone in need will get access to this high quality full length content. And that being said, students, I'm Muralidharan Gopalakrishnan. I completed my MS in Electrical Engineering from one of the top ranking American university. I'm also an IITian who completed BTech from IIT Guwahati. I have 4+ years of experience preparing students for or coaching students for IIT JEE and other competitive exams. And students, if you are looking for a complete package, the Champions tool for your JEE preparation, be it JEE Mains or JEE Advanced, it's going to be Unacademy subscription any day. Why do we say that? Because we have the best educators across the nation. We in fact have authors of your popular books like DC Pandey and DC Gupta on our platform, with whom you can attend daily live interactive classes on a very attractive and interactive platform with polls and leaderboards. That way your learning becomes very interesting. And not only that, we provide lots and lots of test series. Also along with that, you will get analysis using which you can improve upon your overall performance. And you will also get access to one of the most important component of your Unacademy JEE preparation on Unacademy subscription. That is going to be a live doubt clearing session. In fact, you will have lots of live doubt clearing session. In fact, your fourth session is going to be live doubt clearing session on every single course that you're going to go through. Every course on Unacademy is well structured. You don't have to worry about the planning. It comes with dedicated doubt clearing sessions and quizzes and mega quizzes. And moreover, Unacademy subscription does not restrict you by any batches. And we provide you unlimited access throughout the period. So yes, you can enroll to as many programs as you want. And how do you avail an Unacademy subscription? Do log in from your app or web-based version. Click on the left-hand top corner extension bar, select select IIT JEE as your goal, and hit on this get subscription button. And students, you know your program the best, but let me tell you, if you are a 2021 aspirant, probably you'll be going for a 6-month program. If you are a 2022 aspirant, you will be going for a 12-month program. And if you are a 2023 aspirant, you will be going for a 24-month program, since it's going to be a 2-year-long journey. But let's say you are a 2021 aspirant but planning to take a drop, you may want to go for a 12-month program. And we do typically have two components of the subscription. One is plus is what we just discussed, and we also have something beyond plus known as iconic subscription. On iconic subscription, you will get all the features of plus, but additionally you can get one-on-one mentoring session, personal coaching from IIT and NIT alumni who are educators on our platform. So think about it, IIT and NIT alumni who have previously gone through this journey will be able to guide you efficiently throughout this journey, because they have also successfully cracked the exam and they also know the ups and downs. They will be giving you that motivation that you need, and they will be providing you the strategies and expert guidelines to prepare for the exam and to successfully crack the exam. So this is about our iconic subscription. And if you go for 6-month plus subscription, it's going to cost you near about 25,000. If you go for 1 year of your plus subscription, it's going to cost you less than 35,000. And if you go for a 2-year plus subscription, it's going to cost you like 50,400 for 2 years, near about 25,000 per year, less than 70 rupees a day. And you can also go for iconic subscription. If you can afford it, it's going to be one of the best things. And if you go for a 6-month iconic subscription, it's going to cost you near about less than 35,000, 34,200. If you go for a 1-year iconic subscription, it's going to cost you 58,500. If you go for a 2-year iconic subscription, it's going to cost you 90,000 for 2 years. That comes down to like 45,000 per year. and make sure you're applying Murli live code, be it you go for like plus or iconic, any kind of plus or iconic or even combo subscription to get maximum discount. Yes students, we have recently introduced something known as combo subscription. So what is this combo subscription? Combo subscription is nothing but we have introduced an economical complete package for both your JEE and CBSE board preparation at an economical cost with the best educators across the nation. And yes, you can do this now with our combo subscription, and this is totally possible students, and it can go as low as less than 90 rupees a day for 2-year subscription and less than 120 rupees a day for 1-year subscription. Make sure you apply Murli live code here as well, because even on combo subscription your discounts are applicable. So yes, that being said, let's get into this lecture. There are different combinations of combo subscriptions. We'll discuss that at the end of this lecture. So yes, these are all not 2019 PYQs, it's all 2000 18, 16, 15 PYQs, etc. But anyway, very interesting questions is what we have, very practical questions is what we have in today's session. Let's get into this lecture and understand what has been asked. So what is being asked? What is the minimum energy required to launch a satellite of mass m from the surface of the planet of mass m and radius r? Okay, so now here's the thing, what is the height you have to launch it at? 2r. Okay, so you are supposed to launch the satellite. Okay, think about it very carefully. Let's get into this problem. Generally, we miss out a very small thing here. So let's say you have like a satellite, okay, on the surface of Earth. Now what you need to do is, of course, you need to give it some initial energy, and you need to make sure okay. So this planet has some radius r, and what are we supposed to do is we are supposed to launch it at an height 2r. Now here comes the thing, you're supposed to launch it at an height 2r, the same satellite. What should be the satellite doing? This is one of the important points you should not be missing out. I hope you already got it. It's something to do with conservation of energy. Of course, that is all correct. But what is the thing that you need to understand? In this case, okay, it's actually a very simple problem. Okay, I will sort of tell you why it is so simple. You will understand it. Okay, see, first of all, in this case, you need to understand this one thing. If you understood it, the problem is done. What is it? Now the satellite has to also be orbiting. It's not like you launched a satellite, then left it at that height. That means it will just reach the height. But you want to make sure it is in a circular orbit, right? Like in an orbit. Generally, we are just talking about circular orbit. In rare instances, we are just discussing about this elliptical orbit. We in fact discuss some questions around them, which can be your potential JEE mains questions. Do check out last lectures of your gravitation theory sessions, so you will be getting information on it. So now the thing is, it has to make this circular orbit. Okay. First of all, let's understand the thing. Then your satellite is at this point, that is in this orbit. There is some binding energy associated with it, and there is some, not like binding energy, it's some total energy associated with it. Binding energy comes for your electrons and all, but we say some energy is associated with it. And how much is it generally? Minus x by 2. Okay, I'm just giving it a name like minus x by 2. If you remember, x is just something unknown. Then what is potential energy? Because we don't want to calculate mv square, half mv square, etc. So we are taking this method to solve it. Then your potential energy is minus x, and your kinetic energy is how much? is plus x by 2. Okay, first of all, let's do a thing. Okay, what is the first thing that we are supposed to do? We are supposed to find out the potential energy at this point. Quite simple. Why? We are supposed to find out potential energy, and then we get the answer on the total energy, and then we equate the energy, end of the problem. So this is why, some things are very important that we are discussing. Some of you might have not covered this theory. If you haven't done it before, definitely do complete it. So yeah, if not, just understand it right away, right here. You can also prove this point, but yes, this is how it works. So how much is the distance from center of Earth? 3r. So we are supposed to actually find out the potential energy for 3r distance. Okay, or a 3r distance, and the satellite has a mass m, and given to you planet as mass capital M, and potential energy at 3r distance is going to be how much? Let me quickly wrap up this question. We have nothing to do in this case. Okay, so potential energy at 3r distance is going to be how much? From the center of the Earth, it's 3r distance. It's not at an altitude of 2r, and center of the Earth 3r, same thing. Okay, minus g m by 3r. Okay, now coming to this point, okay, it's the same thing. Okay, so now why did we write it down again? If this is minus x, what is the total energy at this point? Half of it. This is minus x, this is minus x by 2. So energy is going to be how much? We are only concerned about energy. Forget the way you typically work around what is the kinetic energy, what is the potential energy, etc. We are not worried about all of those stuff. Minus g m by 6r. Done. Major component or the major part of your problem is done. Why? This is just conservation of energy. Okay, so your satellite is here, and the satellite is supposed to have what? Initially just some potential energy associated with it. Okay, and that potential energy is something like r, and here we know the energy at the I2r from that surface. The energy. Okay, we just calculated it. Okay, what I'm saying is, then you give it some energy or kinetic energy, whatever it is. Kinetic energy is that energy in this case. Okay, so this is that required energy that you need to give. So your objective is to give some energy like E plus of some potential energy at this point. What is the potential energy at this point? It's quite simple. At a distance r from the center of Earth, it's minus g mm by r. Given that m is the mass of the planet and small m is the mass of the satellite. And what do we know? It should be total energy at this point. Plus 3r distance. So what is the value of E? We have E plus of minus g m by r is equal to how much? Minus g m by 6r. So energy is how much? E is how much? How much kinetic energy you're supposed to give? Do that math. It goes on the side. It becomes positive. You will have 6 minus 1, 5. So it will be like 5 by 6 gm m by r. You'll come across multiple solutions for this problem, but you know what, if you understood this method, this is the easiest method. Okay, so if you're looking at it, we have solved it literally within 2 pages, even not 2 pages if you're doing it you know, like with all the kind of shortcuts. So this diagram, etc., it's probably on only 1 page. Okay, it's quite a simple problem. The answer should have been like a 2 minutes problem is what it would. Okay, now we have a very interesting problem here. So let's get into that problem and understand how to solve it. Okay, it's a really interesting problem. So there are 2 particles of equal mass m. We have done a very similar problem. We have even done a little advanced problem of this. So there was like 4 particles, I guess. Okay, that 4 particles thing was asked twice in your JEE mains, once in I think 2016 or something, and once in JEE Advanced, once in your recent JEE mains. Okay, this is the first time, I guess. Okay, but you need to be careful around the math. That's all you need to do. Okay, so there are 2 particles of equal mass m. They go around a circle like a merry-go-round of radius r, and under the action of their mutual gravitational attraction. Then what should be the speed of each particle with respect to the center of mass? Okay, what should be the speed of each particle with respect to center of mass? Okay, let's get into this problem and understand it, how to solve this problem. It's quite an easy problem. Okay, now the center of mass is stationary as such. Okay, first of all, you need to understand that point. So what is happening is, you have one particle, it has some mass m, and you have another particle which also is a very similar particle. I'm just using different colors to differentiate them. Now what is happening is, these 2 particles are moving in a circular path. Okay, due to mutual gravitational, like, you know, so we would also have a center of mass of these particles. So let's say they are exactly at the opposite diameters. Then in that case, this is going to have, like, this is the direction of rotation, then this is going to have a velocity like this. Okay, let's say this is going to have v, then this is also going to have v. But in opposite direction. And you know where your center of mass lies? Of course, at the center of the circle. Okay, for the system, always the center of mass will be at the center of the circle. If they are diametrically opposite to each other, it will always be at the center of the circle. Okay, fine, nice. If it's at the center of the circle in any of the given situation, and this center of mass is not moving, what is the velocity of center of mass? 0. If your center of mass is moving, then only it makes sense for your center of mass to move. This particles or this path has to be like a spiral or something. It's just you know, moving in a circle. So that means your center of mass is not moving. Okay, and a very important thing that we need to understand is, what is the distance between these particles? Okay, it's making, okay, first of all, what do we know? We know it is making, you know, a revolution in a circular orbit with radius how much? Capital R. Now, coming to this point, what is the distance between these particles, not r. This is where the mistake can happen. It is like 2r. That's it. Hi Naveen Kumar. And that means what is your this thing velocity of one of the particles I have to assess. First of all, we know few things. Okay, we know centrifugal force should be matched with your gravitational. Okay, and what is your gravitational force in terms of magnitude? Of course, gravitational force is going to be negative. G, here mm we do mm, but here both the m's are equal, so we'll be having something like mm by, generally we have distance between them r square, something like that. Yeah, the distance between them is not r but 2r. Okay, and what do we have? Centripetal force to be mv square by r. 1m gets cancelled out, and this is, sorry, mv square by small r is nothing but that is also 2r. We can just quickly correct that point as well. So this is like 2r. And what is your v square going to be? V square is going to be like gm by 2r. That means v is going to be how much? Velocity is going to be, sorry, speed is going to be gm by 2r under root. End of your story. Both these velocities would be having the same magnitude, or sorry, both this velocities would be having same magnitude, so both these particles would be having same speed. That's it. End of the story. That's it. Why we aren't doing with respect to center of mass? Because center of mass, your velocity is 0. Really simple. Okay, here your center of mass velocity is 0, so you don't have to worry about anything. Okay, simple question, easy question. Again, this could have been a bumper question, easy to score. Yeah, of course, that is one of the things. Okay, now we have a very interesting question. And yes, students, make sure you're completing all the PYQ sessions. We have discussed so many problems in your gravitation, a very important simple chapter. And post this, we'll be also having magnetism session, which is going to be a last magnetism PYQ session. We have completed everything. We are taking up JEE advanced level magnetism questions. Okay, so now let's get into this. So we have two bodies, one as mass m and the other as mass 4m, and they are at a distance r. The gravitational potential, very interesting, intuitive, and a really nice question. So gravitational potential at a point on line joining them where the gravitational field is 0 is how much? Do you think where the gravitational field is going to be 0, there your gravitation potential will also be 0? No, there is no such point where your gravitational potential is going to be 0. Why? What is the reason? Because your gravitational potential is a scalar quantity with always a negative symbol, which adds up to give up a larger negative, or a very smaller negative, whatever you like to call it, another negative quantity. It cannot be 0. Yes, gravitational field is a vector quantity. It can be 0, but your gravitational potential cannot be 0. Okay, I hope you got this point. Okay, that being said, let's start with our calculation. Anyway, you should be very confident about these kind of problems. This is like a good level of problem, not the best level. You have seen the best one yesterday. Yesterday's problem was that killer problem in your gravitation. You can never expect a better problem than that. Definitely, that is one of the best problems in your gravitation. You have a cavity, like literally same kind of question you can expect in electrostatics as well. First of all, let's take a point P. Okay, I'm going to do a thing as usual. We'll be assigning some color codes to mass M. Okay, field is going to be in this direction, E due to mass m. At a point P, we are going to say at a distance x from m, and at a distance, how much then from 4m? That should be from 4m, the distance should be like how much? R minus x, because R is the distance between both of them. Very simple, damn simple problem. Okay, the pull is going to be in this direction. We can simply say, we are supposed to find out that null point. Of course, it's not going to be on the either side, because on either side it would be pulled towards the mass. Let's take for an example, if you have doubt around this here, the pull due to small mass m or 1m is going to be in this direction, and due to 4m is going to be in this direction. That means it is never going to be like 0. And similar, it's a vector quantity, right? Only vector quantity here in this case can be 0. Okay, I'm not saying scalar quantity cannot be 0. And similarly, even in this case, what is going to happen? The pull due to 4m mass is going to be in this direction, and due to m mass is going to be in this direction, and it can never be 0 again. So this side also non-zero. We are wondering, why did we only calculate the middle value? Why not outside that? Because this is also non-zero. So we can only work around this point P, where we have that 0. So to find out P, we took a distance x from m and r minus x from your 4m, and we would be saying that field due to m is equal to field due to 4m. Okay, very simple problem, damn simple problem, because the numbers are also very friendly, if you understood that part. And what is the field due to m? Field due to m is going to be minus of gm divided by x square, and this is equal to minus of g into 4m divided by r minus x whole square. End of the story. You got everything that you need to solve this problem. Now just start solving this problem. Minus minus goes off, mm goes off. What do we have? We have something like 1 by x square is equal to 4 divided by r minus of x square. And then what we are, so you'll be having two solutions here. We are not concerned about the other solution. Okay, you'll be wondering why not minus x is not valid. Okay, we already discussed why it's not valid, because on this side and this side there will be a non-zero field and non-zero field, because direction is going to be the same, like attractive direction due to both the mass. And this implies, what is this? I'm just taking root on both sides and just keeping the positive quantity. I would be having what? Minus x, 1 by x divided by r minus x. Okay, let's find out what is the value of x. It should be like okay, let's solve it. So if I take an inverse of that quantity that we had, 1 by x is equal to 2 divided by r minus x. What do we have here? X is equal to r minus x by 2, and you take this 2 on the other side, and what do you get? You get something like 3x. This becomes 2x. You get 3x. 3x is equal to r. That means x is equal to how much? R by 3. Okay, x is equal to r by 3. You have one of the results that you need. And what else do we know? We know the other thing as well. Like this is r minus r by 3. How much this should be? 2r by 3. End of the story. Simple story. Now what are we supposed to do? We are supposed to find out this r by 3, I mean like the distance from small m is r by 3 and capital M is like 2r by 3. We are supposed to find out the potential at this point. That's it. Yes, it's really a very simple problem. So potential at P, that is the point where the gravitational field was 0. Why did we do all of this calculation there? The gravitational field was 0, is going to be potential due to M added with potential due to 4M. Okay, now M, what is it? It's going to be minus of G into M divided by R by 3. Okay, it is R by 3. And minus of G into 4M, right? Due to 4M, it's 4M mass, yes. And distance is how much? 2R by 3. End of the story. Almost, we have approached the end of the story. I would say this is the end of the story. We have a little bit more in the story. That is just few calculations that is left. Like, probably half a step for many of you. So minus GM small m, I guess it's minus G small m by R. I'm just taking out that as common. And what do we have? We have 1 by 3 goes on the top, right? 3 plus of 3 by 2. Yes, everything is fine. Oh no, we did a small mistake. What is that small mistake? It's a huge mistake. Oh, we missed the 4 into. Okay. So what are we getting? We are getting something like 6 and 3. So it's going to be like 9. So potential at point P is going to be minus 9 times 6 plus 3 Gm by R. Done? Simple. Okay. Okay, answer should have been 4. Little surprising answer, but this is what it should have been, because your distance is going to be less than r. That is one of the ways of intuiting it, but I don't think you can guess the answer from the given options unless you calculate. Okay, now we have a very simple question. We have done this question too many times. We can just do it in 2 lines, I guess. So the height at which the acceleration due to gravity becomes g by 9. Okay. So, you know what, we need to calculate the altitude, not the distance from the center of Earth. That's the question. So, we will be taking some r dash. Okay, r dash is what? Distance from center of Earth. Hi, Cheshwara. Hi. I hope you have completed. Good evening, students. Good evening, Cheshwara. Good evening. I hope you have completed already the gravitation, because you have discussed so many things in gravitation. So I'm taking that r dash distance from the center of the Earth to be some r plus h, where h denotes the height. Okay. What do we know? We know a few things. One thing that we are already given is field is nothing but G, right? Field on the surface is nothing but G. And what is the value of G? Just in terms of, we are just discussing the magnitude. You can just take it as even the magnitude sign. Yes. And we have also started magnetism, students, so don't miss it out. Very important chapter. Direction is the key. In fact, in JEE Advanced, half of your problems are 2018 problems and 2019 problems would have just been solved if you understood the direction part in your magnetism. Okay, we'll be discussing your advanced problems today, so that will be the last session. I tried taking up different kind of model problems, and yes, that we'll be having the necessary things that we need. Okay, so G is equal to Gm square by Gm divided by R square. We know that. And the other thing that we know is field at that R dash distance, how much? It's G by 9 that is given to you. Okay, how much is G by 9? G by 9 is Gm by R square into that of 1 by 9. I told you this is a very simple problem, but actually what it is, Gm by R dash whole square. Okay, done? Yes, almost done. Nothing is there in this problem. I told you it's a simple one line problem. If you can write it in one line, that could be the best thing that you could do. Yes, you do this thing, substitute the value of R dash. Okay, so what do we have? We have Gm by R square into 1 by 9 is equal to Gm by R dash whole square. Gm by R dash whole square is how much? R plus of H. We are doing it specifically with respect to, like in terms of H, because we need to find out the height. Okay, nothing else. So that's the reason that we are doing this. And here Gm gets cancelled out. If I take root on both sides, what would we be having? 1 by 3r is equal to 1 by r plus of h. R plus of h comes out to be like 3r. That means here h is how much? 2r. Really simple problem, students. See, this is the kind of problems that you get in gravitation. Definitely worth completing all the PYQ sessions, because very simple problems. You can complete this PYQ session within less time. Many problems we have skipped that were repetitive, but we have discussed pretty much all kind of model problems. And even when we have skipped some of the problems have like similar concept. So that way, just complete the PYQ session, attend the the theory session. You will have a complete understanding of them. It's very simple. That's it. End of the story. That's it. Okay, now we have an interesting question here, and this is definitely a very good question. Okay, why this has a lot of calculation, nothing else. This is also an easy question. Easy questions is what you get from gravitation. Gravitation as such does not have any tough questions. You get that point in your mind. Okay, so first of all, mass of the spaceship is given to you, which is like 1000 kgs, and it is to be launched from the surface of Earth into free space. The value of G and R are given to you: 10 meters per second, 6400 kilometers radius of Earth, and this thing, your G. Then what is the energy required in this case? Okay, of course you need to do lots and lots of calculations in this specific case. It's a very simple problem. Probably I think this is the last problem that we'll be discussing, because with this we have discussed every single previous year question, be it JEE Advanced, JEE Mains. Probability of finding so where did you read this statement for education? Probability of finding the electron is 0 only at infinity. How can we say that? Where did you read this thing? Okay, let's get into this question. It's a very simple question. Okay, so what are we discussing here? We are yes, exactly, escape energy. You have that escape you have that escape this thing. So it has to be launched with certain energy such that it is the total energy becomes 0. Probability of finding electron in most of the places is actually low if you're thinking about it. So let me just give you a short kind of like two things that you need to understand really well. Okay, really good question. Okay, I'll explain you that at infinity zero. I don't know why that was said. It could be something else. She might have meant something else. Okay, potential energy plus of. I'll come to your question. Really interesting question. Okay, I'll explain this question and I'll come back to your question. Don't worry for education. Okay, potential energy plus energy should be like zero. Okay, you know the value of potential energy at this point. If we take mass of Earth to be like m, okay, it's little bit of manipulation, that's it. Okay, G into m, and mass of this rocket to be like small m. Let me complete this problem. It's a 2 minutes problem. Let's complete that and I'll get back to your question. Really good question. Okay, what about electron? Yes, that means this is what is equal to 0. That means what should have been your initial energy that you should have given to the rocket such that it escapes the field. It gets into the free space. It escapes the field, right? That is what is the concept. Okay. That is going to be, it should never fall back, GMM by R. Let me do a small thing. What are we going to do? We are going to multiply with R on the numerator and on the denominator. What do we get? We get something like this, GM by R square, yes, into that of M into R. See, one of the things is, yeah, I'll come to your question. Okay, GMGR. Is that what we have? Yes, that's what we have. Okay, yes, that's it. That is the total energy. That is the initial potential energy, right? That initial potential energy is what you have to give, and it will escape the surface of Earth into free space. Okay, let's solve that thing. Okay, now it's all about numerical substitution. Then we can get into for education's question. So energy came out to be mg capital R. Mass m is how much? 1000 kgs SI units, 10 to the power 3 kgs, into gravitational acceleration 10 meters per second square. Make sure it's all in SI units, the same units they are in. Okay, into how much? 6400 kilometer. Convert this into meter, else we are doing something wrong. 64 into 10 to the power 5 meters. Okay, now you will get the answer. It's not at all a big deal. Okay, I don't think there is anything in this question, like even you need to calculate actually to the power 10 correctly. That might be the twist. Let's check it out in the answer. What is the twist? It's 64 into 10 to the power 4, 10 to the power 9, right? 10 to the power 9 joules. Or probably it would have been given as 6.4 into 10 to the power 10 joules. Now let's get into your question. So here we have a very interesting question from one of the students. What is the probability of finding electron anywhere? Okay. Definitely they have confused you at the units. If you have missed out that like 3 zeros, probably you're thinking this is the answer, but this is not the answer. This is the answer. Okay. So what is the probability of finding an electron? See, probability of finding an electron as such, okay, just coming from your Bohr's theory model, it's like most of the spaces is empty, so it's very low. Then we get into Heisenberg principle. We can never predict like the position of your electron. Okay, so probability of finding an electron is probably low, but it may never be zero because there is always electrons in the free space. There are atoms, so I don't think it is possible. So what your teacher might have meant is like you have kind of moved to place. I don't know what is the reason. Um, I don't know, like, probably at infinity you have nothing. So that's why probability of finding an electron. So you should have nothing to find no electron, right? Electron, finding an electron probability is going to be low. We understood that from the Bohr's model, right? That that the cold foil experiment that was conducted, most of the space is like going to be like an empty space. Then comes Heisenberg principle. Heisenberg principle says you can never predict momentum and position all along, because even predicting the position of an electron is very, very difficult, very low. There will be always an uncertainty associated with it. So that way you can never predict the position of an electron. Probability of finding an electron is low. In a real space, it is never going to be like zero, because you have a material, you have an element, you have a compound, you have an atom associated with it. So it's never possible. Or maybe like you just have like helium nucleus, then probability of finding an electron is zero. Okay, just just a bunch of helium nucleus in a box or something like that. But other than that, I don't think in infinity it can be set as zero, assuming that there is nothing in the infinity. Okay. Yes, students, tomorrow if you have missed gravitation up until now, you can attend tomorrow's session. Tomorrow I will be choosing few of those questions that is kind of very necessary questions for your JEE mains. Probably will take up 2020 JEE mains question and discuss it from 10 a.m. to 12:30 p.m. Do not miss it out. Today we have completed current and electricity PYQs. Make sure you are completing them as well. It's a free special class on your Unacademy learning app, so don't miss it out. Gravitation PYQs at what time? 10 a.m. on your Unacademy learning app, and yes, to 12:30 p.m. And students, that being said, do not forget to complete electrical measuring instruments in one shot, which was conducted on 2nd of September. It's also a free of cost special class available on your Unacademy learning app. So why should you do this? One is like you definitely get questions from electrical measuring instruments. You typically get 3 questions from your current and electricity, and one could be from your electrical measuring instruments, or it could be also be more. Okay, so yeah, and all you have to do is attend this one shot lecture. This one shot lecture is going to take only 4 hours. Within that 4 hours you can pretty much grasp, or we have discussed every single concepts in your electrical measuring instruments. This includes like galvanometer, moving coil galvanometer, design torque on a moving coil galvanometer, and like how to convert galvanometer into an ammeter or a voltmeter. Why shouldn't we use a voltmeter? What is the difference between ideal voltmeter and like an ideal voltmeter and an practical voltmeter? And why shouldn't we use voltmeter, and why should we use potentiometer? Application of potentiometer, like measuring EMFs, comparing EMFs, measuring internal resistance, as well as meter bridge, and some like errors associated with meter bridge, which includes end correction, least count errors, etc. And in this session we discussed your JEE mains, JEE advanced problems in the single 4-hour session with all these concepts. It's a one-shot lecture on your electrical measuring instrument, so do definitely attend it and complete your preparation around electrical measuring instruments. And that being said, students, do get onto a Telegram channel. First of all, download Telegram app if you don't have one, and then click on this link which is available in the description box below, because post that you'll be getting onto a Telegram channel where you can get live before time updates on every session conducted by our JEE English team. We also keep you updated with the latest news about your exams and any updates or breaking news about your exams. Okay, and yes, of course, I provide information on what we are doing today on your Telegram channel. So yes, you can also just type in JEE_English and find us on Telegram. So yes, that being said, if you're looking for a complete package for Unacademy, if you're looking for a complete package, it's going to be Unacademy complete package for your JEE mains or JEE advanced preparation, because we provide the best in class educators with whom you can attend daily live interactive classes on a very interactive and attractive platform with polls and leaderboards. That way your learning becomes very interesting, and not only that, you'll also get access to lots and lots of test series set by the best educators, post which you will be also getting analysis using which you can improve upon your overall performance. And not only that, students, You'll also get access to lots and lots of live doubt clearing session along with every program. In fact, in fact, every program is going to be well structured. You don't have to worry about the planning. We take care of the planning on our end. So think about it. You don't care about the planning. We do the planning for you. We conduct the courses for you. We plan the courses accordingly. For an example, we have started courses for 2021 aspirants, 2022 aspirants, 2023 aspirants, by Bansal educators, vibrant class educators, by some of the best educated team, and as well as we have recently started a 10-day crash course as well, and I'll come to that point. And yes, that being said, and that you can also access for free. And that being said, every course is going to be well planned. It's going to be systematic, and not only that, you get unlimited access throughout the period. There are no batch restrictions on Unacademy subscription platform. Okay. Hi Free Fire, hi, we are at the end of the lecture and we have completed Gravitation PYQs. Do attend the Magnetism PYQs, okay? And students, if you're a 2021 aspirant, you know which program you should be going for. You should be probably going for 6-month program. If you are a 2022 aspirant, you should be going for a 12-month program or a 1-year program. You can also be a 2021 aspirant planning to take a drop. Or you could be like a 2023 aspirant, then you want to go for a 24-month program. And students, we discussed about Plus, the features of Plus, but we do have something beyond Plus as well, that is iconic subscription. Yeah. Gravitation completely completed, students. I don't think any concept is left over. If you want, you can attend tomorrow's gravitation session on Unacademy learning app. There I'll be taking up selected problems, most probably like what kind of problems has been asked in 2020, and we'll be discussing those. So don't miss it out. And yes, students, that being said, yes, your iconic subscription is something where you can get one-on-one mentoring session, personal coaching from IIT and NIT alumni who are educators or an Unacademy subscription platform. So think about it. IIT and NIT alumni who have previously gone through this journey and would have successfully cracked the exam will be guiding you in this process. They know the ups and downs. They will be giving you the motivation, and they will also be guiding you with necessary strategies and expert guidelines to make it happen. And yes, coming to the pricing part, a 6-month plus subscription is going to cost you near about 25,000. 12-month plus subscription is going to cost you less than 35,000, and a 24-month plus subscription is going to cost you 50,400 for 2 years. That is near about 25,000 per year. That is less than 70 rupees a day. And if you go for a 2-year iconic subscription, it's going to cost you 90,000. That comes to how much? 45k per year. It's only 45,000 per year. Okay. And if you go for a 12-month iconic subscription, it's going to cost you near about 58,000. And if you go for a 6-month program of iconic, it will cost you something near about 34,000. That is less than 35,000. And make sure you're applying Murli Live code so that you can get the maximum discount on your subscription purchase, students. Okay, you'll be able to avail maximum discount by applying Murli Live code even on combo subscription. Yes, we have introduced something known as combo subscription, where you can get your JEE test preparation and CBSE board preparation at an economical cost with the best educators across the nation. So yes, students, we do also have different combinations of your combo subscription, iconic plus, and full iconic, and we also have plus and plus, and we also have plus iconic, and your it's going to start at 3,037 per month if you're going to go for a plus and plus. And make sure you apply Murli Live code even on your combo subscription, because you'll be getting discounts even on your combo subscription. So make sure you're applying Murli Live code here as well. And that being said, you can take your JEE preparation to next level with our team, with our JEE English team, where we have a team of IITians and NITians and head of coaching institutes. And we will be conducting JEE workshops, expert guidelines for your personal coaching, for your exam preparation. So yes, you can do that with our team as well. And that being said, we have just launched we are going to launch your Revisathon. Okay, Revisathon is going to be launched on 6th of February. It's going to be 8 days, 50 intensive sessions with 26 educators, where you can get your full JEE revision by the top teachers. and it's absolutely free. Make sure whenever you're enrolling, you do apply Murli live code. Okay, I think it's a special class. But anyway, students, do not forget to like and share this video. Definitely do like this video and share this video on your social media platforms like Telegram channels, WhatsApp groups, Facebook groups, because it's a high quality full length lecture. And we have completed your gravitation PYQs. So work hard and smart to achieve your success. Avoid any gossips. Keep smiling and do apply Murli live code whenever and wherever necessary. You can unlock Unacademy Combat for free. You can unlock your trial subscription for like a week or a month or something by applying Murli live code, and you can unlock many more features on Unacademy subscription platform by applying Murli live code. So make sure you're applying Murli live code whenever and wherever necessary. And today at 7:30 p.m. we will be having our last magnetism. Okay, last magnetism session, so don't miss it out. Yes, it's going to be very interesting. All right, students, see you in the next class. Take care, stay safe, bye bye.